tomorrow will be better. In this other video, I want to take you a little bit to physics and more specifically to mechanics. This is a past GC question, advanced level GC. So in this question, we are given a mass. We are told that this mass is released from rest on a smooth inclined plane as shown on the board, and then the length of the plane is also given. And we are told that we should find the acceleration down the plane. Next is to find the time that it takes to reach the base of the inclined plane. And finally, the friction force which is required to bring this object to rest when it gets to point C. Follow me, dear friends. Solution. Alright, these are very key words in this problem because when we are told that it is released, usually released here implies that it didn't have an initial velocity, alright? So release means that the initial velocity is 0. And smooth plane has a connotation, which is the fact that there's no friction, alright? So that's the implication of the smooth plane. So how do we go about finding the acceleration down the plane? Unfortunately, we cannot use any of the 4 equations of constantly accelerated motion because we don't have enough information for this. However, we can use the second law of Newton, which says that F is equal to ma. But for us to use this, we have to first of all resolve all the forces acting on our mass, alright? So vertically downward, we have mg. Along the incline, we have mg sine theta, and then perpendicular to mg sine theta is mg cos theta. Because of time and space, I won't reproduce this diagram here anymore. Okay, so in the absence of any other force along this incline, why? Because there's no friction. So the only force along this incline which causes motion is mg sine theta. So we're going to equate mg sine theta to ma, alright? So this implies that ma F is equal to ma is equal to mg sine theta. Now the m's can take off themselves, and so we have that constant acceleration we are looking for will be g 9.8 times sine 30. And if you do this very well on your calculator, you're going to have that a will be 4.9 meters per second square. Guys, watch out for the units. Okay, now this is the answer to question A. Now as for question B, find the time to reach B. Okay, now we can use one of the equations of constantly accelerated motion because now we have the acceleration which is constant, and we also have the distance. And right now, the first equation that comes to my mind is a third, or I don't know whichever position it has, but it says the distance is given by initial velocity times time, and then plus half a t squared. Now, what do we know about this first term? We know that this is going to boil down to 0. And why? Correct, because it was released. So release means initial velocity is 0, guys. Don't forget this. Okay, so if I apply this and simply make t the subject of the formula correctly here, you can pause this and make t the subject of the formula. It's going to be equal to the square root of 2s, 2 times s divided by a. And we just got the a. And if you substitute each value correctly, you obtain 2 values of t. Why 2? Because we can see here that t is raised to the power 2. So it's a quadratic equation here. And it should therefore have 2 answers. And the result of every square root equation should give you 2 answers, a positive and a negative. But we're going to take just the positive answer. Why? Because there's no negative time. Dear friends, be careful, alright? So if you punch your calculator well, you're going to have that the time will be 1.8 seconds and not negative. Now let's come to the heart of the question. Now they say find the frictional force which is enough to bring this object to a stop. Now this second part, well, because of space, I'm still going to exploit just this. So it means our object N is about to start the second phase of its motion. Pardon me, I have to reproduce it here. So this is C and then this is B. This is our object here about to start this new phase. But be careful, while it is about to start this new phase, the force which it brought from the first phase still stands because it hasn't yet made any opposition yet. So we have here that we still have mg sine theta as a driving force forward. And now comes in a new force, which is a frictional force, and which is what the question wants us to calculate or to compute. So we will denote it by F and then subscript R, right? And we are told that this distance here is 15 meters. So let us find the frictional force such that this object is going to eventually come to a stop here. Now, we are going to once more use the second law of motion of Newton, which says that F is equal to ma. So to do this, we will have to resolve forces. All right, we are going to resolve forces around this body. Now mg sine theta is the only force driving it forward, so I have that mg sine theta now minus frictional force, because friction now opposes this motion. All right, it's equal to ma. Good. So without wasting time, let me start first by making this the subject of the formula. All right, so if you make fr the subject of the formula here, you're going to have that fr will be mg sine theta minus ma. Okay, now let me ask you a question. Do you know why fr has a negative sign? Of course, it's simply because we know that fr, the frictional force, opposes the motion. Okay, so it takes a negative sign. So in this new equation we just established, we need to find the new acceleration. Be careful not to make the mistake and think that this A is the initial acceleration we had in the first part of the motion. No, in the first part of the motion there was no friction, but now there's another reality which sets in, which is friction. So A has to be something different. And let me surprise you that here A will be a deceleration. Oh yeah. Why? Because our object is slowing down and eventually comes to a stop. So we are dealing here with a deceleration. How do we get this deceleration? We will use one of the equations of motion, which says, and typically the last one, which says that v squared. So here we can make statements like, but from v squared is equal to u squared minus 2as. Dear friends, instead of plus, why do I put minus here? Because once more, just like we did up here we are already aware that we are already aware of the nature of this acceleration, and we already know that it's a deceleration. So we just have to put a negative sign here. Okay, so let us make this A the subject of this formula. This implies that acceleration is going to be equal to u squared divided by 2 times s. Now, where have I left out v? V is going to be equal to 0. And why will v be equal to 0? Because at point C, the object has to come to a complete stop. And complete stop implies that the velocity, the final velocity, is 0. Now, I don't have u once more. This is another problem. I don't have u. How do I get u? U here stands for the initial velocity of the second phase of my motion. U stands for the initial velocity of the second phase of my motion. But take note here, this initial phase, this initial velocity of the second phase is in essence the final velocity of the first phase. It's a two-phase motion which is continuous. Okay, so the initial velocity here for this second phase is the final velocity for the first phase. So it's just sufficient for me to get the final velocity for the first phase, and I can obtain it. So you say, but u here is equal to v of phase AB. Okay, so let us get v of phase AB. Now, we will use the very first equation. V of phase AB is equal to u of phase AB plus A of phase AB times T of phase AB if you want. But u of phase AB, again, what is it? 0. Very good, because once more it was released. So this gives us a 0 here. So let us get v of phase AB. This implies that v of phase AB is going to be nothing else but A of phase AB, which we obtained as 4.9, times T of phase AB, which was 1.8 seconds. So v of phase AB, which once more is equal to u of phase BC, is going to be, if you punch in your calculator, you're going to have that this will give you 8.82 meters per second. Be careful with units. Now let us round up with this. So with this value of u, we are going to obtain our deceleration, all right? So we will say this means that A is going to be, if you like, A of BC, is BC, all right? Is going to be equal to u here all squared, 8.82 all squared divided by 2s. The distance s is 15, so 2 times 15. Therefore, A is going to be, if you punch well in your calculator, you're going to have that A will be 2.59 meters per second squared. Dear friends, be careful with the units, okay? So with this value of A, we just come here and we look for our friction force here, okay? So we're going to have here that friction force is therefore going to be equal to, now we have that mg sin theta, we have each of these values, m 0.5 times g 9.8 times sin theta, which is 0.5, and write sin 30, minus, we have now ma, which is 0.5, and the mass times the new acceleration we just had, which is 2.59. And if you punch correctly on the calculator, you will have that this value is going to be nothing else but 1.15 Newton, dear friends. It should be in Newton because friction is in Newton. And this answer makes sense because your friction has to be significantly, or however, but less than the driving force. Okay? And why is it easy like this? Because tomorrow has to be better. Thank you.